Okay, we were at this function, the info function. If I want to know the information regarding the data frame, I can simply give df.info, and it's a function, so round brackets will be there. And you'll get all the details regarding the data frame. Now you can see this, the column names have been given, then not null values, the count values, and the data type as well has been mentioned. Okay, so we have, as we have already changed the first two fields to date time, you can see we are getting date time here and some objects and the float data type. Right? It also mentions the total d types. So we have two fields of date time, one float and four objects, and also the memory usage. Okay. Now, if I want to go further and try to found the unique start locations. Let us do some functions here. Uh, Suppose I want to find out how many unique locations do I have. So the location is in the start column, right? The start asterisk column. So if I want to do that, I can just write df square bracket, the name of my column, so which is start asterisk, okay, dot value counts, okay, and the round brackets. When I run this, I get this. You can see this. These are my cities, and their counts are given. So carry is some city name uh, for which there are 201 records. Then there's something unknown locations are there for 148. Then Morrisville is there, Gila is there, 85, and so on. Islamabad is also there, 57. Now, suppose I want to see only the first few records, I can make use of the head function. And when I run this, you can see this, I'm getting only the first five records. Okay, now let us see some data manipulation functions, especially relating to selecting, indexing, then filtering and sorting and so on. We'll also see the group by function. Okay. Uh, to start with, the first function which I would like to show you is the indexing function, especially positional indexing function, which is iloc, ILOC. Okay, and this is a function which is supported by older versions. In the newer version, I think it has been replaced with a new function called LOC, that is log function. Now, the major difference between these two functions is the ILOC takes the index positions, the values, the rows, and the column numbers, whereas the LOC function takes the column names as the parameters. So to just give you a simple example of iloc, if I suppose want to access the first, you can say first four rows, and I want the first and the, let us say the third column, okay, to be displayed. I don't want the whole, all the columns to be displayed. So I can give df.iloc. Okay. One more thing, even though this iloc is a method, or you can call it as a function, you'll find that the round brackets are not used in this case. We make use of the square brackets. This, especially why? Because we are going to pass the numerical values, which indicates the index positions of the rows and the columns. So when I give the function iloc, see that you do not make use of the round brackets. Instead of that, make use of the square brackets. We give 0, colon, and 4. This is my the first four records I want. Now, why four records? If you start with the first row, which is index position 0, and go up to 3, right? The first four. It won't include for the fourth index position, right? Comma. After giving the comma, I have to indicate the columns which I want to display. And while giving the column, it has to be a part of a list. So it has to come again in a square bracket. Here, because I'm giving two different, you can say column headings. So it is 0, comma. If I want the fourth or the third one, the fourth column, which will be index position 3. Okay. And when I run this now, here you can see I'm getting the start date, and uh, this is what I got. Now, while converting, there's some problem here, not a time. N80 is been displayed. That means it is not converting the date format into a time. So let us make some changes. And what I'll do is I'll re-execute this line. I won't change the date into date time where we had. Okay, let me read this again. So I'll read this again. And now, instead of executing the change date time change, I'll execute this one. Here we go. Okay, so here you can see might be the date time format was not the right format which I had given. It is MMDDYY or something like that. So that's the reason why it's not working. Okay, so this is how we access the first four records. Okay, so it's starting with 0, 1, 2, 3, up to 3, and not it won't go up to 4 here. And the column number 0 is your start date, and column number with index position 3 is the start column. Okay, we can also mention that if I want to change this, I want instead of the third or the fourth column, I want the first two columns. So I can give 0 and 1. Okay, and here you can see we get the start date and the end date. Okay, both have been displayed. What if I want to mention the first four columns? Okay, I need not give a 0, comma 1, comma 2, and so on. No, I can give the colon. So I can give colon and 4. One more thing, because I'm giving a series here, you do not require this square brackets anymore. If I keep the square brackets, then it is going to give generate an error. Okay, so if I run this now, you can see I'm getting the first four columns. And if I include, let us put this square brackets back here. Sorry, yeah, this one more. And now run this. You can see this error is come. Fine. So whenever you want to specify the column, different columns without the colon, if you want to give the comma, say in the previous example where we gave 0, comma 4, 0, comma 3, 0, comma 1, that was working, but it has to be in the square bracket. And if I have to specify the range, then I'm going to make use of the colon, but the square bracket should not be included. So remove this and then run it. You will get the first four columns and the first four rows as well. Now, this is positional indexing because I'm using the function ilog. Now, the new function which is available in the new version of Pandas, or you can say Python, is your log function. Now, log function is label-based indexing. Label means the name of the column. So if I have to access something using the log function, I can again make use of the square bracket. That is, I want everything from in the rows, and I want the columns, say start underscore date. Okay, and the asterisk, I also want another column as category. Say category, GORY, and I put a asterisk sign. Can run this. Okay, what happened? Is something wrong? Line number is required. Okay, sorry, I have not given the square bracket. It has to be, this has to be in a list. Okay, so I need to include, whenever we have multiple columns, I need to put it in the square bracket. Here we go now. And suppose you have only one, I actually intended to give one. So if I remove this, and you, in this case, you do not require this. Here we go. Now, if you look at the difference between both the outputs, you'll find that in the previous, when I passed it as a list, I got the column headings as well. Now here we do not have the column headings. It directly returns a series. Okay, if I want to know what data type it is, you'll find that this has been named as an object here. Okay, so if I want to pass multiple columns, then you require the square brackets. So I can just give a comma, double quote, category, and there's a asterisk. This looks fine, and one more square bracket missing. So here we go. Fine. So I got the start date and the category as well. Okay, so this is how we make use of the log function, especially when we want to access the column using the name of the column. Usually, the log function is more frequently used compared to ilog, because whenever we are accessing a huge data set, you won't remember the column position, okay, whether it's 0, 1, 2, 3, 4, 5, 6, 7, or whatever, it might be more than that. The best way is to use the column names. And if I'm using the column names to access the columns, then I need to make use of the log function and not the ilog function. Okay, there are some uses of ilog as well. So when we go ahead, we might come across some use of ilog as well. Now let us take some simple example where I want to extract. Let us say I want to extract 5 rows, and I want the columns as the start date and the miles to be displayed. Okay, and here I want to access only values which are like greater than say 10 for miles. Okay, so what I'll be doing is I'll be using some filtering here. So depending on the condition, I want to access my records. So let us do that. What I'll do is I'll create another data frame, say df1 equal to df.loc. Okay, and let me put it in square bracket. So the condition is I want all the records where the miles or the distance covered is greater than say 100 miles. Okay, so if I have that condition, I can put the name of the field here, miles, and put the asterisk sign. Okay, that's the name of the asterisk sign is why I'm putting it, because that's the name of the column greater than say 100. Okay, and what I want to display here, I want it, let us not put anything. I'll just show you this first. Now, what happens in this case, if I give a condition like this, it is just going to give me true or false. It's not going to return the, so if I run this, right, because it's df all greater than, yeah. So all the values which are greater than this has been displayed, but I don't want the whole record. Okay, I want only this column miles. Okay, so if I want only miles to be returned, then what I can give is I can give a comma here, and I can mention the name of the field which I want. So the name of the field again will be a part of a list here. So I need a square bracket, and I can give, sorry, miles and the asterisk sign. Let me store this in a df1. Okay, and let me first run this. This is working fine. And in this, I'll display df1. Here we go. So here you can see in the previous example when I gave it, where I did not mention the name of the column which I wanted to return, it displayed all the rows, all the columns, okay, and all the rows having miles greater than 100. Okay, these are my records. Now I can also, if I want, I can display the first few records as well. I can change this to say as here I can just give head 5, just give head. Okay, those first 5 records will be displayed. One more thing you can notice is the index is the old index, the index which is coming from df and not df1. So it is not again starting with 0, 1, 2, 3, and so on. Okay. Now, if I want to access the records, let us say I want to access the first record. So whether I should make use of the index position 232, or should I make use of 0? So please try it out whether we will be able to access the first record of DF1 using the index position 232 in this case, or 0. Okay. You can also re-index or reset the indexing. We will see one example later on. If I want to re-index it, let us take one more filter. If suppose I want to find out all the, you can say all the rides, which is starting from New York. Okay, and I want to know that data. So instead of say comparing miles, now I can write df dot loc into square bracket, df square bracket again, and because the start position is in start variable, start asterisk, I can make use of the equal to sign, double equal to sign. Please remember the single equal to, as you know, is the assignment operator, and your double equal to sign is your comparison operator. And I can compare it, say New York. I hope the contents are saved in proper case. And what I want to return is I want to return the miles. So I can again give in square brackets, please. Give it in square brackets, miles. Okay, if I want more than one, I can also give another as well. Say I want the start as well. You can give it, but right now I'm not. I'll just run this. Okay. So here we go. We get some records here. There are some 4 records, which is starting from New York, and I've written the miles for that. Clear? So you can give such types of what different operators, whichever we have learned, less than, greater than, equal to, not, all that can be, used while doing the filtering. Now, one more way, suppose, let us say I want to check for 2 values. Say I want to find out all the rides which are starting from Cary and say Morrisville. So if I want to do that again, now instead of using LOC now, I can also directly make use of the df function. I can say df in the square bracket. I can give say df from start and the asterisk, the square bracket completes, give a dot here, and the function which I'll be using is in function. Okay, is in what? So all the values will come in the round brackets here, and again it's a list. So I have a name called Cary and Morrisville. So MORRIS. Right. So square bracket completes, round bracket complete, even this gets complete. And if I want, I can run this, and where you can see, even without making use of the LOC function, I can write the filter and get the answers. Okay, so either you make use of the LOC function, or you can directly give it like this as well. If I want to make use of the LOC function, then I need to give it like this, df dot LOC like this, and this will remain the same. Okay, so df into square brackets. So if I run this one also, you'll get the same answer. Okay. So in such examples where if you want, you can make use of the function itself, LOC, or without LOC also it is going to give you the same return. What if I want all the other records which is other than starting from Cary and Morrisville? So if you remember the not function, the tilde sign, so I can make use of that here. So I can just put a tilde here, the not sign. So where it is, here it is. There is some question here. Let me execute this one first and I'll answer you. Okay, here we go. So here we are getting all the other, records which is not starting from Cary and Morrisville. Okay, so can we do this with 2 columns? Of course, we can do it with 1 column, 2 column. The number of columns hardly matters. Okay, but there is a different way of doing it. For example, if suppose we have to do some filtering or comparison. In that case, when we have, let us take an example. I'll take another example for that, for multiple columns. If I want to compare multiple columns, you can compare it. So I'll take one example later on. when I come to that. Now, let us say I want to find all the trips which is having say distance greater than 10 miles and originating from Cary and Morris. So I have two conditions here. Okay. So if you want, you can also give multiple conditions, right? Now, the first condition is based on the column start, that because I want to find out all the trips which is actually starting from or originating from Cary and Morris, whereas the other one is the miles. I also want to compare the miles. Now, if both the conditions has to be satisfied, that means I have to make use of the AND operator. Okay. So if I want to do that, let us do that, and I'll store all the results in another data frame. So I'll make use of df1. I can write df1 equal to say df.loc, the square bracket. Now df square bracket. I'll write the first condition for the start star. Okay, like we in the previous example also I made use of is in function. So is in into round bracket. Now this time I have changed the name of the cities. It is Cary is seen, and instead of Morris Villa, I am giving only Morris. Okay, so this is my first condition. Let us execute this first, and I'll display this one. Here we go. So I'm getting all the cities, which is starting with, you can say starting from Cary and Morris. Now I want to add one more condition. I want to add, now you can see there are 201 rows which is fetched. So what I'll do is I'll use the AND operator. So I can give a space here, and one more thing, please remember, if I'm using multiple conditions, this whole first condition should come inside a round bracket. So I need to give this in the round bracket first. So this will come in the round bracket, and then the second condition will come in the next round bracket. So here I'll give df square bracket. This time I will be comparing miles. So asterisk sign. Now I want greater than 10, or you can say greater than greater than 10. Let us use greater than 10. Round bracket complete. And now I can run this one. Here we go. So instead of now 210, I've got some records here. Okay, all the records. I don't want all the records to be seen. Let us display the head. Only the first few records. There is this one. Yeah. Okay. So here you can see now all the values. Miles is more than 10, and I have given two conditions. Okay. Now the only thing is, as I told you, it has to be in round brackets. If I do not give this in round brackets, let us remove this. And I give an AND here. I remove this bracket as well. Now, even this looks very valid to me. Okay, but when I run this, okay, no records have been fetched. Okay, there is a problem. So please remember, whenever you're using the AND operator, the first condition should be enclosed in the round brackets. So this should be this is my first condition, followed by the second condition. Okay, and now when I run this, I get the output. Clear? Now, if you look at the indexes, as in the previous case also, whenever we apply filters, your indexes are the ones which is coming from the old data frame. Now in df1, if I want to reset my indexes, there's a simple function called reset index. Okay, so what I can do here is I can give df1 dot reset underscore index into round bracket, okay, in place equal to true. Okay, and then I say I display df1. Now you can see this. What's happened is I'm getting the new index positions, but there's one more thing which is happening. The previous index is still there. Okay, this is my previous index from df, and this is my new index which has been reset, and I'm getting the new indexes as 0, 1, 2, 3, 4. Okay, if I want to remove this index as well while resetting it, so I need to pass one more parameter. So I'll give a comma here and I'll drop equal to true. Okay, now when I run this, here you can see what happens. Drop equal to true. I hope this works. Right? And df1. No, it is not dropping it. In place equal to. Okay, I need to check this out, why it is not dropping it. But please remember, what should happen is with this function drop equal to true, and df, we are resetting it. We are getting a new index position, and the previous indexes which we have should be dropped from this particular data set or data frame. I will recheck this one. What is wrong with this? Let me change this to in place equal to true, and because I have tried this out and it does work. Let me display some value. 10 records. Now my data is giving me all the values. Okay, there's some error here. Head. To find this might be I need to write df1 equal to. Let us check this one. Okay, and then I run df1. Yeah, fine, great. But where are the records? df1 equal to df1 dot. df1 non-type object has no attribute set. Okay, let me run this one again. Okay, here we go. Reset, and yeah, here we go. Fine, there was some, I think it was acting a bit funny, but finally we got it. So remember, we need to use the reset index function, in place equal to true and drop equal to true. This drop equal to true is actually going to remove the column index which was there in the previous data frame, this one. Okay, and a new index has been generated. Now this is starting from 0 and 1 and so on. Clear? Let us quickly do some few more functions and then we'll stop. We'll do sorting now. I'll just show you sorting, and then when we come next, we will go ahead and check how to add columns and so on. For sorting, it's a very simple function, sort values. So if I want to sort it, say df, I want to sort underscore values into round bracket. Now here, I need to specify the name of the column. So by equal to, let us give by miles. So I give miles and asterisk. Okay, and comma. You can also sort by multiple fields. I'll just show you one example. Let us see this one first. And we have to mention whether it will be ascending or descending. So for that, we need to mention ascending equal to, either if you want it to be true, you can make it true, or you can keep it false. Okay, so it will be in descending order. It won't be ascending order. Okay, so ascending equal to false, and you can just check the first few records. Say n equal to and equal to, say I want the first 20 records. Here we go. Okay, and you can notice this the index numbers are different now. Okay, and it is sorted by miles. Now one more thing, because this total column is there inside my data frame, so it is taking that row on top. Later on, I think we should try to remove that total column as well. Sorry, not the total column, the row. That is row number 115555. We'll check that as well. Okay. And if I want this to be in ascending order, then I can change this to true. Okay, run this. And here we go. We have got the first few 20 records here. Okay. Now, what if I want to sort it on two different fields, and one of them I want in ascending order, the other one I want in descending order? Even that can be done. So again, I'll make use of df dot sort underscore values into round bracket by equal to. Now, because I have two columns, please remember I need to pass it as a list. So let us sort it by start, the start date, and put this asterisk, comma, and I want the other ones in my list. Asterisk. Okay. Now, after you give this, I need the other ascending order or descending order. Now, because there are two columns, the first one I want to be in ascending order, the other one I don't want it to be in ascending, I want it descending order. So I can give ascending equal to, in square bracket again as a list, I can give true, comma, false. Okay, and round bracket complete. And now when I run this, you can just check the records. Here we go. So this is my first is into sort as per the date, not the date, sorry, start, that is the city. So you can see this has been ascending order, and the miles is in descending order. Okay, we will stop here today. I think we have taken an extended session, and I want you all to practice this, especially practice it in Jupyter, because henceforth, whatever coding, whatever programs I'll be doing, because we are slowly moving on to with machine learning, some codes and all. I want you all to practice it with Python. With Jupyter. Clear? If you have not loaded, please see that you load Jupyter. First of all, simply download your Anaconda and run it. You'll get Jupyter notebook along with it. Okay. So let us stop here today. When we come next, I'll show you a few more functionalities of your data frames, which is basically used because as you know, when we access any files, we'll be handling data frames more than anything else. Okay. So data frames and your arrays are the two most important things, especially when we are doing machine learning. Okay, guys, if you have any doubts, please, again, I'm requesting you to practice this out, because without practice, I think you won't be able to understand it better.